Alright, we're going to take a look at this program. This is the first program that actually has header files. Now this guy didn't follow convention because the actual application is this. This is where the main statement is. So don't pay attention to how this idiot named this stuff. Okay, what we have in here, we have some includes of our local header files, and the parentheses are the quotation marks, tell the compiler to look, or the linker to look in the local directory first for the files. Greater than and less than brackets here, the angle brackets as they call them, say look in the standard library location. So using the standard namespace, we have this little preprocessor directives here, out of the book, looking at the operating system, see if it's a Windows or a Linux operating system, just for shits and giggles. And down here I actually plant that because it's defined as a variable platform. So, that kind of just prints it out. This will be a constant, in essence, when a program actually runs. It'll be set in stone when you compile it. So, these two little functions here are actually defined here, which, like I said these inclusion guards aren't necessary. Programming once takes care of a lot of the reason they had this in here. Because that book, uses like a fucking C compiler off the internet or some shit. So anyway, but like I said here, if you uncomment it, it works fine. So, but this, this is not like a preprocessor function, because you can do a lot of shit with preprocessor directives. But this is actually just a regular function, and it's saying, hey, if it's not already defined, well then go ahead and define it, otherwise ignore it. Now you can, well, let's look at the triple function here, and that includes the add function, add header. So, because this uses the add function to define another function called triple, which is simple enough, just triples it. So, pretty self-explanatory, but if you'll notice, we do have, add declared here as well as triple. So normally you might worry about that creating a circular dependency, but it doesn't in this case. So, but yet, according to Chile, those can still be a big issue. So, I don't know. I'm sure I'll run into that problem eventually. Okay, but we actually have this class defined in this program as a calculator class, and it's under the very descriptive term of ops. So calculator class has some public methods defined and some private member variables, properties defined, numbers, character for operator, and then a status. Okay, if you go into the implementations file, the CPP file, you can see the definition. This is a constructor, sets the status to true by default, and then it launches. You got a launch function here defined, which really just prints out instructions. That's really all it does. Again, and then we got read input function, which accepts user input, and you can see it's got a it puts a caret on the screen, and you're supposed to enter a number. And when you do, first key you type, it tests it for equality to 0. If it is 0, then your status equals false. But that's all it does. Technically you could still continue entering keys, I think, and you could actually, and it will ignore all the others because status is false. So You'll see what the significance of that is later. But then we got a write output function, which if status is true, okay, if it's false it won't do this, but if status is true, it'll do a switch statement, and it can do that in line just like this. So just like this, you can do a lot of operations. Oh, and by the way, okay, this, if the status is not 0, then it'll actually read in the next character, and, well, actually, it will, no, it doesn't matter if it's 0 or not, it'll still read in the next character looking for an operator, okay, or looking for, then looking for a number next. So we have, successive CN statements taking care of that. So it'll prompt you and wait for an input, then prompt you and wait for another input, then prompt you and wait for another input. So, and then it'll come over here and do its thing and do the switch case deal, and it looks for the operator, which is a character variable. And so you can see the note beside it, to store input operator. So, and if you look at the header file, you can see that we've got everything notated, so you can hover above the characters, for each and every one of these variables and actually see what it says. You store input numbers, etc. So those notes, these notes over here show up. But at any rate, it'll perform operations based on the numbers, depending on its addition, subtraction, multiplication, or division. Which division, it makes sure that it's not 0 and puts a note out here, if it is, they did enter 0, for a divisor. So, and then we got the run, and the run command, go figure, returns the status. So, so if we look at the use of it, we define the object, and then it out of the heap, and then it launches the calculator function. Okay, and then we have this loop. It says while pcalc dot run is true, in other words. So while the status is is 1, see, it's false only in that event, otherwise it's true, as we saw up here. So, so as long as that's true, it'll actually, execute this function and this function over and over and over again. So it'll keep trying to read input until you start entering something, and then it'll pause, while you enter your data, and then when you're done entering your data, with the final CN statement, you pressed enter for the last time, then it'll go and start writing, call that write output function, which will perform the calculation, and then it'll circle back around, and then wait for another input. So, anyway, let's go ahead and run that, even though there's some other garbage in here. Okay, so, you can see, that what that function did. Now it's waiting for a number, so 5 times 79. Oops. So if I enter that, that's going to screw it up. Okay, so, well, that's how it dealt with the error. It's interesting. Okay, so it did output it. So, times 24, equals 136. So you gotta, enter 336, so you gotta enter one line at a time. So, You can't just enter it all in one line, but then if you go 0, it'll stop out, and then it runs the next code, which has to do with random numbers and stuff. We'll get into that. Okay, so anyway, that's a simple object. At least it does something moderately useful. It's probably the only moderately useful program in that short book. Although the lotto program, okay, it's maybe more useful. Could win you $1 billion, right? But so what we do next is, again, this has got a bunch of bullshit in it that, like I said, doesn't work about catching errors. So looks like they're trying to, create the assert statement, which, is in the assert library. Anyway, but, this, just ignore all this crap. This is dealing with floating point numbers and exploration of the random function. Let's go ahead and run that again. 0, so it stops out. Okay. So, kind of shows you what this is sort of doing. Okay, that's a 1 there. But basically, we're defining a lot of floating point numbers. I don't know why I'm doing that, but ABC equals a random number. So C outing ABC here, so that's the first thing we see out, so it's a 41. So believe it or not, even though I didn't do anything to it, it's an integer. So this seems to output in integer random numbers, even though we're going into floating point values. It seems to output integers. So yeah, there's a return type of integer there. So it's an integer random number generator, so it doesn't matter if you're using floating point or not. That will always output an integer. So then I'm going to see out ABC, then I'm trying to do int ABC, where you see that dash, and so I'm going ABC modulo 10. So since it's 41, it's going to, 1's the remainder, so that's what's going to output. Then we're doing a pipe here, and then it's going ABC equals random modulo 10, so whatever number that came out with, I don't know what it was. Since we don't have a random seed, it should do the same thing every time we run the program. C out ABC, so it's outputting ABC, and then it's just ending, and then then it's outputting NBC somewhere. So I guess the 7 is there's the pipe, so so 7 is its random number modulo 10. So then after that, this has got to be 1, so I'm going 99 modulo 2, equals 1, which is true. There would be just 1. Basically, again, the effect of modulo, and you're going to see that here in a second, is like establishing a range limit. So, and it's all because of the fact that you're dividing a number like by 10, for example. So, like, I don't have a clue what the number was they divided, but whatever it is, it had 7 left over. So it will always return a number between 1 and 10, and maybe between 1 and 10, or 0 and 10, or something. So, the fact of the matter is it always return, range restricted number. And, if I did this as 100, it could return a much larger number. etc. I don't know what the return range of the random function is, but I could be all of integers, which means could be up to 4 billion. So, but like for example, I could go, between 1 and 1,000, rerun it, go 5 times 72 or 78 and 0. Okay, so now that returns 467. So okay, and okay, so you kind of get an idea how that works, and that's because if you divide a number like 17,379 by 1,000, the fact of the matter is it's going to have a remainder. Okay, and its remainder has to by necessity be between less than 1,000 really, because if it was 1,000, then it would be the next increment, and the medulla would be 0. Okay, so in other words, this is essentially dividing, in essence, any number up by 1,000, for example. So it'll divide any number by 1,000 chunk into 1,000, and if there's remainders left over, you're good to go. Now, of course, if that original number was less than 1,000, well, you would still have a remainder because, it wasn't able to divide any times into it. It went 0 times. So anything up to 1,000 will be a remainder. So then if you, enter like 999, there's going to be 999 returned. But if you enter 1,000, okay, well 1,000 will go into 1,000 once, so the return would be 0. If you enter 1,001, okay, well 1,000 divided into 1,001 is 1, because it'll go into it 1 times, but with a remainder of 1, so it'll return 1 and start all over again. So just to further clarify, it was really kind of hard to understand this at first. The random number section. Okay, now right here you have random numbers. Alright, that's nice and dandy, so it goes and generates like a shitload of random numbers. Now how this works is interesting. Okay, this is, srand, we're actually seeding our random number generator. Okay, we're declaring an array of numbers, and this is part of the lotto program. It's kind of the meat of the lotto program, which we're going to get to next. But it's actually seeding our random number generator with it's having to convert time, which is returned in some kind of, I'm not sure what type, but at any rate, it's converting it to an integer. It's casting it to an integer, and it's entering 0, so it's going to return the number of seconds since like 1969 or some shit. So, so it does that and seeds a random number with it. So every time you start the computer, the time will be different because there's going to be more seconds since 1969, so basically, every time it'll actually return a really good random number that's just thrown in there as a seed into whatever algorithm they use to determine random numbers. So, so it'll ensure a truly random number every time, and then we're doing a for next loop and populating the array, and this is funny looking for next loop that you can do that in C. It's all in a single statement, and it'll just execute this over and over and over again, so you can have one semicolon, is my understanding, and have that work. Anything else you need a scope resolution, scope brackets. So you need to declare a scope, like we do here, So this goes in, basically populates an array, with random numbers, between 0 and 49 for a lotto draw, okay, so, and it's adding 1 to it, so, because there's not a lotto number 0, so that ensures that it'll return actually between 0 and 50, or 1 and 50, I guess. And then it's C adding J, so this is printing our numbers. I put this in here, and that's where all that garbage comes from. Just showing what it's doing as it's going and experimenting around with it because I was confused. And like I said, these questions are all wrong, so I answered them. My statements, I answered them. But, k equals, this actually goes through, and it's kind of interesting how this works, but it actually goes through, the entire array and, juxtaposes all the numbers. So, um, in a random fashion. So, that's what's kind of weird, because see, j equals a random fashion, and we got a set of numbers that we defined up here, between 0 and 50. So the array actually has just one copy of each number in it, but what we want to do is scramble the numbers. So that's what this does, but it doesn't generate a number that gets put into the array. What it does is it just scrambles them in a random way. So, j equals random, okay, and then C out, J, etc. Let's again ignore that. But K, equals, our nums I, okay, which is our array there. So, and our I, works between 1 and 50, okay. So we will start with 1, basically, and then we go nums 1 equals nums j, okay, and j is a random position. So, that's setting the number in our array equal to a random, a random position in our array. So that could be from, again, 1 to 50. And then it's going nums j, which is the position that it's accessing, equals k. So, but it does is it basically swaps the numbers in these two locations with one another. But it goes through it and does, for each number, it does that. So it'll go 1, 2, 3, 4, 5, etc. Until it reaches the end of the array. Continue swapping numbers the whole step of the way. So some numbers may get swapped several times in that process. But, it'll percolate the array that way. It's almost like the balls bouncing around in the selector, at the lottery. It kind of has the same effect, because of how they do it. But, so in the end, we get a nice disordered array of numbers that have been randomly, and by random number selection, scrambled. So it's an interesting combination scrambler is what it is. So, it's worth keeping in mind. It's actually somewhat clever, I think. At least from my perspective, it's somewhat clever. Then we're just outing and saying, hey, your lucky numbers are this, and then it's just simply reading off the first 7, which is like picking balls out of a bin. The first, 7, 1 to 7 numbers. So, well, actually 6 numbers. So, anyway, then it's outing that as part of the loop. So, so again, this is one of those self-contained single line for next loops. So, that's what it's doing, is printing out our lucky numbers, and ending, and doing a pause, and, the rest is history. So, it's pretty cool how that works. So, it was, at least a very, very, very small reward for reading that book, but, so you can see, again, those are your lucky numbers. That could be worth $1 zillion. It could be worth $1 zillion. So, anyway, that concludes that little study. So,